Another injection system and a total difference injector as compared to splitless injector is the on-column injector. This is another geometry of injection, and this injector is used especially for the analysis of compounds with a high boiling point. So only with this kind of compound you can use the on-column injector. This column, the on-column injector, is used for easily degradable compounds because it helps the volatilization of the compound directly in the column. So there are an introduction directly into the column without prior vaporization. And then we have a progressive vaporization in the column. So the difference between the direct injector and the on-column injector is the fact that in the direct injector you have the glass liner, remember the glass liner, the septum, and you perform the volatilization first in this glass liner before the transfer in the column. In the on-column injector, you perform the vaporization directly into the column without prior vaporization. So the first step is the vaporization directly in the column, and you begin the separation. Here you have the representation of the on-column injector, and there are some difference between the classical splitless injector. You see that there are no more septum. So here you have the syringe, the column, the capillary column here, directly linked by the gas vector, which is the carrier gas in French. Here you have the needle, and you inject directly in the top of the column with some heater block to perform heating, progressive heating of and progressive vaporization of the compound. So you have the on-column injector, and you have some advantage of this injector. The first is the no discrimination and thermal degradation, because this is a progressive vaporization. No breakdown of fragile substance, linked, of course, with the thermal degradation. And there is no septum, because we don't need to perform the vaporization in the glass liner. But there are, of course, some drawbacks, very important drawbacks, especially it requires to use diluted solution, because we don't divide the sample as in the split injector. So this is not made for a very concentrated compound, very concentrated sample. We also have some pollution of the column by non-volatile compound, because we inject directly on the column. So of course everything is injected in the column can perform pollution. And there are no possibility to automate. Then of course that's a problem if you want to perform high throughput analysis. I just focus about the liner and some slides about this part of the injector, because this part of the injector is very important. The liner represents the inlet, the glass liner here. You have two different glass liner with different ferrule or term O-ring, which allow to perform potentiality of the system, because you need, of course, potentiality of the system if you work with gas to avoid any leakage. So this system is very important, because this allows to perform in that place, in the glass liner, you perform the volatilization of your compound. And then for sometimes you need to wash this place to avoid any pollution. So you have different geometry of this liner, and you can change the liner with the same injector system. So this is the first point of contact of the sample with the chromatograph. So this represents the first point of contact of the sample, and it allows the vaporization of the sample in this liner before the injection in the column. It allows to change the quality of the injection because we can perform some difference. There are different properties of the liner. For example, there are different diameters, so you can inject a big or small volume of sample depending of the diameter. You also have the possibility to modify them chemically and then to allow some online derivation of the sample directly in the liner. For example, you can realize some derivation of the sample, so chemical derivation, directly on the liner before injection in the column. There are a large number of liners proposed on the market, and then, of course, the choice of the ideal liner is very complicated. It means that there are a lot of compromise to choose the good liner for a good application. And of course, there are also ability to chemically activate or disable the liner if you want to perform the derivation of your sample or not, and then to increase the field of application. Here is just an example of a catalog of different liners. So you see that you have each liner are described here with this schematic representation. You have the different properties of the liner with, for example, diameter. If you have some modification, you can derivation, you can have some added in the liner, etc. The nature of the injector. So this is liner for direct injection. Here, this is liner for splitless injection. In that case, this is splitless 2 and split liner. So you can choose your liner depending of the nature of the injector. So if I work with a split injection, I need to choose my liner in this one. And after that, I have to see the properties of the liner to choose the good liner for my application. So if I work with, for example, small molecules and volatile small molecules, maybe I have to use this one or this one, I don't know. This is an example, and then I have to be careful about the choice of my liner. Because here you have an example about the injector and the column. You see here, this is bad and this is good in French, I'm sorry. This is the results obtained for two separation. The only difference is that in that case, injector and column inlet fold, and in that case, injector and column inlet are just cleaned. And only the fact that we cleaned the injector, then we cleaned the glass liner and the column, allow to increase the efficacy of the separation. So remember, the efficacy is the number of plates, and the number of plates represent the peak sharp. Then you see here we have, of course, sharper peak as compared to this one. This is not good. The separation is exactly the same. So the only issue is the fact that we have just to clean our inlet, our injector or column inlet. Another example, here on the choice of the inlet, we have to choose the good one, because here we have a bad separation corresponding to this compound, and if I choose another inlet, an adapted inlet, I don't know the nature of the inlet, but there are just a modification about the glass liner, and if I choose the glass liner on the same analysis, you see that we have a better efficacy of the separation with 3 good peaks. In that case, we have some peaks, but the resolution is not good. So we have good separation here.